Hi folks, let's do some minimum velocity circular problems. Here goes. A roller coaster contains a nearly vertical loop that has a radius of 4.5 meters. So we have a radius of, did I say 4.5? I don't know, I'm talking silliness, aren't I? How about 7.4 meters? At what minimum speed must the roller coaster be going at the top of the loop so that the passengers will not fall out of the cars? Here's how this works. If you have a vertical loop-to-loop, the minimum velocity is a situation where the centripetal force is exactly equal to the force of gravity. So the centripetal force will be equal to the force of gravity at the top of the loop-to-loop. Well, centripetal force is going to be mv squared over r, and force of gravity is going to be mass times acceleration of gravity. We don't know the mass of our little roller coaster cars and people, and so that's going to fall out. We're looking for velocity, so we've got v squared over r equals acceleration of gravity. If we solve that for v, that's going to be radius times acceleration of gravity square root. So the minimum velocity to just stay on that vertical circle is going to be the square root of 7.4 meters times 9.8 meters per second squared. And let me grab a calculating machine. 7.4 times 9.8 square root, and I get 8.52 meters per second is the minimum tangential velocity. All right. Next problem. How fast would a Ferris wheel need to revolve in revolutions per minute in order for the passengers to feel weightless at the top of the ride if it has a diameter of 15 meters? So we have a Ferris wheel. We have a diameter of 15 meters. So if it's 15 meters diameter, that means its radius is going to be half of that. So 15 divided by 2 is going to be 7.5 meters is going to be the radius. Now we want to create a weightless situation. So what do I mean by weightless? Well, weightless is kind of the same situation we just talked about in the previous problem. We have to create a situation where the centripetal force is exactly equal to the force of gravity. When that's what's going on, then what we're going to have at the very tippy top is the minimum velocity just to go around, or the velocity just to go around is going to be equal to the acceleration of gravity times radius. So how fast to just go around at the tippy top? Well, it's going to be the acceleration of gravity, 9.8 meters per second squared, and our radius, 7.5 meters. So let's do that. 7.5 times 9.8, square root that, and we end up with 8.57 meters per second is the minimum velocity. Now, that's meters per second, but we want to know revolutions per minute. This gets a little bit tricky. There's a couple different ways to do it. In one of the previous problems I did it one way. This time I'm going to do it a little bit different because we want to convert to revolutions per minute. Now, we can look at this from the point of view that revolutions per minute is a frequency. Okay, revolutions per minute is a frequency, where revolutions is just a word, that's just word in the English language, and minute is a time. So if we could figure out period is 1 over frequency, we would be in much better shape. So let's see what we can do with the information that we have. We've got velocity. We know the velocity to go around a circle is 8.57 meters per second. We know the distance that's traveled is 2 pi r, and we're trying to find time. So the velocity in the circle is going to be 2 pi r, the circumference, divided by the period time. So time is going to be equal to 2 pi r divided by our velocity, the 8.57 meters per second, or the period, time to go around once, is going to be 2 times pi, the radius, 7.5 meters, and 8.57 meters per second. So time to go around once, 2 times pi times 7.5 equals, divided by 8.57, I end up with a period of, I'm going to do that again because I just don't trust myself right this second. That didn't look right to me. 2 times pi equals, times 7.5 equals, divided by 8.57 equals, I got 5.50 seconds is the period of revolutions. Now, I want frequency. So frequency is 1 over period. So 1 divided by 5.50 seconds. So I'm going to take 1 divided by 5.50. So I'm going to end up with 0.182 hertz, or per seconds, is going to be my frequency, but I want revolutions per minute. So I have 0.182 per seconds, and I want to get that per minute. Get rid of seconds, go to minutes. There's 60 seconds in a minute. Take that times 60, and I ended up with 10.9 revolutions, remember, is just a word, it's not a unit, per minute. And that is how fast it would have to rotate in order for people to feel weightless at the top of that ride. All right. Do I have time for one more? I think we're going to try and see if we can do that. Here goes nothing. A stunt pilot in an airplane flies in a vertical loop-the-loop maneuver. She flies a vertical circle with a radius of 3,200 meters, and she has a speed of 200 meters per second. How many G's is she pulling? Well, the G's, it's going to depend a little bit if she's on the top or the bottom of her arc. So let's see what we can come up with. Centripetal acceleration is going to be v squared over r. So velocity is going to be 200 meters per second squared divided by radius, 3,200 meters, and 200 squared divided by 3,200, we end up with 12.5 meters per second squared is centripetal acceleration. Now, centripetal acceleration, to get G's is acceleration divided by the acceleration of gravity. So 12.5 meters per second squared divided by 9.8 meters per second squared. So I'm going to divide by 9.8, and I end up with 1.28 G's is the G's pulled by this pilot. Not too many G's for a stunt pilot. They pull many more than that. What is her apparent weight at the bottom of the loop-to-loop? If her true weight it is 712 newtons. Okay, here's what's going on. At the bottom of that loop-to-loop, she is going to feel a centripetal force pulling her inward, and the force of gravity is going to be pushing her down. So the net force on the pilot, the force net on the pilot, is going to be a combination of the centripetal force plus that force of gravity. And this is going to then be a combination of the centripetal force on her, which is going to be mass times centripetal acceleration plus mass times the acceleration of gravity. Well, we know the force of gravity on her is 712 newtons. We know the centripetal acceleration on her is 12.5 meters per second squared, but we don't know her mass alone in order to figure this out. So we're going to find her mass. We have to find her mass. So mass is going to be equal to her weight divided by the acceleration of gravity, which is going to be 712 newtons divided by 9.8 meters per second squared. Her mass is going to be 72.7 kilograms. I'm going to plop that back up here, 72.7 kilograms. And so the net force is going to be 72.7 times 12.5. Let's do the math on that. 72.7 times 12.5. So I'm going to get 909 newtons plus 712 newtons. And so the sum of the forces on our little stunt pilot is going to be 1620 newtons. There we go. That will do. We'll see you later. Bye-bye.